Okay, this is the last unit in this chapter, reasoning about special quadrilaterals. So our goal is to identify special quadrilaterals based on limited information. Okay, so first of all, let's review what is quadrilateral. Quadrilaterals are any kind of polygons that has four sides, right? So all of these here are examples. Then it further breaks down. We can limit them if we say that for any quadrilateral that has two pairs of opposite sides being parallel or congruent, then we have a parallelogram. So if it's a square, rectangle, rhombus, and this parallelogram all meet that criteria. But if we only have one pair that's parallel, like this one, and the other pair is not parallel, we have trapezoid. So we break down quadrilateral into two groups now. Then we can further classify that for, excuse me, if I have a parallelogram that all interior angles are 90 degrees, I would have a rectangle and a square. Or I can have a parallelogram that all four sides are congruent. Then I have a square or a rhombus, right? And finally, if I have a parallelogram with four sides being congruent, with four angles, interior angles being 90 degrees, I would have a square. And lastly, on this side, for trapezoid, I can have a trapezoid that the base, the top base and the bottom base are obviously parallel by definition, but the legs are being congruent, so I would have an isosceles trapezoid. So those are the classifications of the special quadrilaterals. These more specific ones at the bottom here, those are the parallelogram, rectangle, rhombus, square, trapezoid, and isosceles trapezoids are called special quadrilaterals. So here's a follow-up. This I will walk you through because this is actually rather challenging. But it's easiest if you look at it this way. It says a square is always, we can go this way, right? A square is always a rectangle. But if we go this way, it's always a, oops, that's an H. Rhombus, that's how you spell it. And then if you go further up, it's always, a square is always a parallelogram. And it's always, if you go further up there, is always a quadrilateral. And you can do the same with rectangle. You can say a rectangle go up is always a parallelogram and always a quadrilateral. Okay, so finish the rest of it. You go from the bottom up and follow that sequence. And also think through what you wrote. Is that always correct? And the answer key is posted on the website. So let's see how we can use this as an example. Determine whether the quadrilateral is a parallelogram, trapezoid, rectangle, rhombus, or a square. So first of all, let's see. The diagram shows that CE is congruent to, C is incongruent to EA, and DE, which is here, is congruent to EB. So what this is saying is that is the diagonals bisect each other. Then you can think through what we've learned, that if you recall that if any, by theory 6.9, you know that the quadrilateral is a parallelogram. Because it doesn't matter what kind of special quadrilateral it is. It has to be, whether it's a square, rectangle, a parallelogram, or a rhombus, all of them, the diagonals bisect each other. The only exception is trapezoid, and trapezoid is not a parallelogram. It belongs to a different category, right? They're not, their diagonals do not bisect each other. So therefore, as I said, it can be ABCD can be a rectangle, it can be a rhombus, it can be a square. And to know which one exactly it is, we need more information. Here we go. We're asked to identify a rhombus. We're asked, are you given enough information in the diagram to conclude that ABCD is a square? So we know that with these little tick marks here, we know all four sides are congruent. So we know that this is at least it's a rhombus, right? Square is also a rhombus. Any quadrilateral with four congruent sides is called a rhombus. However, for this to be a square, we must know the interior angles are all 90 degrees. And since none of that is given, we don't know, we don't have enough information to draw the conclusion that this is a square. Okay, so use that information, try to figure out these two problems. So finally, here's a third example. It's asking us if we're given enough information to conclude this quadrilateral is an isosceles trapezoid. So first of all, we have to show that it's a trapezoid because E and F, E is 60 degrees, F is at 120. We add the two together, they are supplementary. So therefore, FG and EH must parallel by same side interior angles converse. So we have at least one pair of opposite sides that are parallel. Remember, we call this top base and we call this bottom base. Now, to show that this is a trapezoid, we must also show that the other two pairs, meaning FE and GH, they are not parallel, right? And that is basically saying that we have to prove that EFGH is not a parallelogram. Now, opposite angles of these two, notice that E is 60 degrees right here, angle E, and angle G is 120. These opposite angles, they're not congruent. They are not congruent. So it means that this is not a parallelogram. If I have a parallelogram, see if I can draw this. If I have a parallelogram looking like that, look at my opposite angles. These two angles are congruent, and these two obtuse angles are congruent. The opposite angles are congruent, but these two opposite angles are not congruent. Therefore, it cannot be a parallelogram. So this one, we just proved that it's a trapezoid. Also, we notice that the base angles, notice the base angles 60 and 60, 120 and 120. So the base angles are congruent. So not only we have a trapezoid, we also have an isosceles trapezoid. Okay, so that's all for this chapter, for this unit as well as for this chapter. Make sure you finish these reflections. These are really important. It will really help you understand this chapter better. All right, thank you guys.